This presentation covers series circuits in a bit more detail than our discussion under Kirchhoff's law. Here you see a nice, looks like a 3-volt source down the bottom, and we have shown the direction of electron flow rather than conventional current flow. And we've talked about Kirchhoff's voltage law, that the algebraic sum of the voltage drops around a closed loop is always 0 volts. This is always true, no matter what the components are. In our case, we're talking only about resistors, but next semester we'll be talking about some other kinds of components. A series circuit forms a closed loop. The source voltage is in opposition to the voltage drops across the series components. If the components are resistors, Ohm's law applies to each resistor and to the sum of the resistors in the series loop. This actually gives us some degree of redundancy in how we apply the equations and solve a circuit. Resistors in series add in value. Two 100 ohm resistors in series are electrically equivalent at the two end nodes to a single 200 ohm resistor. Ohm's law applies equally to the two circuits in that the total voltage across the two 100 ohm resistors in series will be the same as that across the 200 ohm equivalent resistor. The current through the two 100 ohm resistors will be 24 divided by 200, or 120 milliamps, and the current through the 200 ohm resistor will also be 120 milliamps. Solving a series circuit. Here's an example. Start by drawing the circuit and labeling the component voltages and the singular current. This drawing is called a circuit schematic diagram. Add the total resistance about the loop. Make sure you have used scientific notation correctly. In the diagram at right, the total resistance is 18 kiloohms. Determine the loop current, I, using Ohm's law. I is going to be equal to Vs, 9 volts, divided by the sum of R1 plus R2 plus R3 ohmic values. In our example, I equals 9 volts divided by 18 kiloohms. Determine each of the 3 voltage drops in the loop using Ohm's law. V1 is going to be equal to 3 kiloohms times a half a milliamp. That's 1.5 volts. V2 is 10 kiloohms times a half milliamp. That's 5 volts. And V3 is 5 kiloohms times the same half milliamp, which is 2.5 volts. And then verify your analysis with Kirchhoff's voltage law. And that would say that 9 volts is equal to V1 plus V2 plus V3. Well, does it? And the answer is, yes, it does, because 1.5 plus 5 plus 2.5 equals 9 volts, which is equal to our supply voltage. This is an exercise for you, designing a voltage divider. Now, I'm not going to walk you through this one. This is one that I would like for you to study, and I'd like you to follow this design, and if you have any questions, then get back to me.